Pythagoras' theorem is used to find unknown lengths in a right-angled triangle. So basically, using this theorem, if you know any two sides of a right-angled triangle, you can always use this to find the third side. But before we get to that, today we're just looking at Pythagorean triads to see if we can identify some. Now, a Pythagorean triad is a set of three numbers that satisfy Pythagoras' theorem. What do I mean by satisfy? Well, I mean you can substitute them into this theory, into this equation, and they'll make it true. Now, the most famous set is 3, 4, 5 because it uses such nice simple whole numbers or integers. So let's write this down. Now, how does 3, 4, 5 satisfy this? Well, let's check and see. Now, we know that 5 is always the long side, and that's the one that we call C. The other two, because we're adding together the square of them, it makes no difference which order we add them. So they can be A and B as you like. But we can see that if we substitute 3, 4, and 5, we can check to see if this is true. Now, the easiest way to do it is to say, well, the left-hand side, 3 squared is 3 times 3, which is 9, plus 4 squared, 4 fours are 16, 9 plus 16 is 25. And the right-hand side, well, that's 5 squared, that's 5 fives, which also is 25. Therefore, we can say the left-hand side equals the right-hand side, and it is a Pythagorean triad. It makes Pythagoras' theorem true. Now, there's a few other sets of whole numbers that do this, but a lot of the time when you're using Pythagoras' theorem to find an unknown side, you end up with two of them maybe being nice whole numbers and some of the others being long decimals or surds or awkward sort of numbers. So it's nice to start with these whole numbers here. So let's see if we can find some other numbers that satisfy the theorem. So let's investigate a few sets of three numbers and see if we can identify which of them are Pythagorean triads and which ones are not. Now, if it is a Pythagorean triad, what that tells you is that if you build a triangle with those side lengths, it will naturally have a right angle in it. So investigating these sets of numbers tells us whether or not they're eligible to be part of a right angle triangle. So how do we do it? Well, we just need to sub the three numbers into the theorem, making sure that you use the biggest number as C. So what we're asking here is 4 squared plus 5 squared, is that equal to 8 squared? Now there's a few ways of doing this. You might like to just write it down like that and then have a look at it. If it's nice simple numbers, you can probably work it out in your head, but if you want to use a calculator, you can go for it. Now here we've got 4 squared, that's 16, plus 5 squared, that's 25. So 16 plus 25, that's 41. What's 8 squared? 8 8s are 64, not 41. So this is not true. Now at that point, you can put a not through the equal sign to show it's not equal. So if it's not equal, then this is not a Pythagorean triad, and if you had a triangle with these side lengths in it, it would not contain a right angle. Let's try 5, 12, 13. 5 squared plus 12 squared equals 13 squared. That's the proposition that we're checking. All right, 5 squared is 25. 12 squared, 12 12s are 144. Add that to 25, 169. All right, now what's 13 13s? You can do it on your calculator or you can do one of these. 13 times 13 and figure it out. Turns out it's 169, exactly the same as this side. So this is true, and this is a Pythagorean triad. All right, let's try 6, 8 and 10. Again, make sure the 10 is the C, because that's the long side. Is 6 squared plus 8 squared equal to 10 squared? Well, let's think. And if you need to do your working on the side, that's fine. Or you could actually do it underneath. You could say 6 squared, that's 36, plus 8 squared, that's 64. Is that equal to 10 squared? 10 squared is 100. Now let's think, is 36 plus 64 100? Yes, it is. So this one is also a Pythagorean triad. Now you might notice this 6, 8, 10, this is actually just a 3, 4, 5 triangle in disguise where all of the side lengths have actually been doubled. So you'll find that once you have sides in a certain proportion that work out as a Pythagorean triad, as long as you keep those sides in the same proportion by doubling them or halving them or multiplying by 1.5 or whatever, you can keep that same proportion and that bigger or smaller triangle will also have a right angle in it.